can be mapped onto itself. I'll show you. By a reflection. So let's say you have the sticky note, and I draw a line down the center of it. That's my line of reflection. If I fold it, it's going to end up right on top of itself. That means it has line symmetry. Okay? And actually it has a lot of lines of symmetry on here. It could be this way, it could be this way, it could be that way, if it's a square, right? So that's what we're looking at today. A rectangle would work too. So that's line symmetry. Yes? Makes sense? Okay. The line of symmetry is the line of reflection in line symmetry. So there's the line of symmetry, that pink line that we drew. Okay, rotational symmetry. If a figure in a plane can be mapped onto itself by a rotation of 180 degrees or less around the center of the figure. So other rotations, we were going beyond 180. This time for rotational symmetry, we're just going to talk about 90 and 180. So for example, in the sticky note, if I have a center right here and I rotate it 90 degrees, does it look exactly the same? Yes. So it has 90-degree rotational symmetry. It would also have 180-degree rotational symmetry, and we don't go beyond that, okay? Because, well, I'll get there in a second. Hold on. Center of symmetry. It's the center of rotation in rotational symmetry. Yeah. It can be rotated clockwise or counterclockwise. So if you were to go to 270, it would almost be repetitive because that's saying 90 degrees the other way. So that's why you only say 90, 180. Or it could be 30, it could be 60, but nothing over 180. Make sense? Let's just look at some of this. All right, so we're going to look at some shapes. See, that's all that's on here. Isn't that cool? Yes. How many lines of symmetry does each picture have? Does the picture have rotational symmetry? If so, describe the rotations that map the figure onto itself. I had a hard time with this last night. So last night when I was doing it, I'm like, okay, I know there's one there. If I fold it in half, it goes on itself. I know there's one here. If I fold it that way, it'll go on itself. And then this one here, that works. And then this one here, that works. And I'm like, okay, 4. The book said 8. I'm like, what the heck? Does anybody see where there could be 4 more? In between each one. I didn't see that. That's hard for me. Some people can see it really easily. So if you fold it here, it will go on itself. In between each of these. All of them. Each petal exactly in half. And so, how many total lines of symmetry are there? 8. There are 8. The book was right. Now, we have to answer the other question. Does the picture have rotational symmetry? Can it be rotated so it lands on top of itself? Anywhere between 0 and 180 degrees. It certainly can. So let's say we start at this line right here. I could rotate it this far. How many degrees is that?
2, 4, 45.
It's 45, right? And then it could be rotated 90. It could be rotated 135 and 180. So 45 degrees, 90 degrees, 135 degrees, and 180 degree rotational symmetry. That's a lot. Can't go past 180 because that becomes just the other direction. That's repetitive. Because rotational symmetry can be clockwise or counterclockwise. Let's talk about the mountain goat. In theory, if you drew a line, none of us are symmetrical, according to what I learned in biology. But we're just going to pretend like the mountain goat is perfect. Okay, so does he have any lines of symmetry? Yes, just one, down the center. Okay, that's really the only place that there would be a line of symmetry. One line of symmetry. Can he be rotated at all? Any rotational symmetry at all? No, there's no rotational symmetry. Yeah. No rotational symmetry. Okay. Turn it over. Alrighty. Any line symmetry in this starfish?
There's lots.
How many people say one? How many say three?
I say 3.
How many say five?
I say 5.
At first I'm like, there isn't any. But watch. If you draw a line here, and that's going to fold right on top of itself, isn't it? Which would be true for each of the arms of the starfish, yes. So you might need to help each other because some people see it quickly, others not so quickly. So there is 5 lines of symmetry.
I think it's really cool.
I didn't hear you, what?
There's 5 lines or 5 stuff.
Exactly, yes. Now let's talk about rotational symmetry. So if I start here, I could rotate it, let's see, I start here. Let's start here. If I rotate it up here, that's going to be 1, isn't it? Rotational symmetry. And then I could go again to here. There's another one. So there's actually only 2. Do you see it? Within the 180 degrees. How do I get that degree measure? You do. Because there's 5 points here. So I'm going to say 360 degrees divided by 5 is equal to 72 degrees. So I have one rotational symmetry of 72 degrees, and within the 180 I've got another one just by doubling that amount. So I could go from 0 to 72 degrees, or I could rotate from 0 to 144. Rotational, that's rotational symmetry. Okay, how about this picture? Lines of symmetry. Reagan, what do you think? You think there's 0 lines of symmetry? I think that's correct. It's because of these little lippy thingies here. Screws it up. If you were to fold it, they wouldn't be on top of each other. So there are no lines of symmetry. How about rotational? Say we start with this one right here. Can we rotate it on top of that one, and then we would have rotational symmetry, wouldn't we? Yes. And so how would I figure out that degree measure?
360 divided by 1.
Yeah, there's 7 of these, what do you call them, ears? I don't know. Petals? Okay, 360 divided by 7. It actually is a kind of a long fraction, so I just rounded. 51.43 degrees is one of them, one of the angles of rotation. If I double that, 102.86 degrees. And can I still get another one in before 180? I can. And that would be 154.29 degrees. So there's 3 angles of rotation here. I don't know. All right, I don't know what that is. A flower combined with a butterfly? I don't know.
They're best friends. They love each other.
Okay,
Can you go back to that one for a second?
yeah. So look at the butterfly slash flower butterflies, whatever. How many lines of symmetry do you think are in there?
4, 5, 4, 8, 9, 10, 12,
Wow.
16. I don't know. 4.
Okay, I know there's one here. I can fold it in half. Yes, there's one. There's 2.
Then there's 4. Because you can split down the little.
I think right here, correct? Yes, okay. Because those will fold on top of each other. And right here,
Whoa. I had a paper on this. And then if you cut it in half, they'll play again.
you can't cut it in half. What? Well, maybe you see something that I don't.
No, you can't. It's symmetrical. Yeah.
I didn't trust myself, so look what I did. I took a piece of patty paper and traced it. And then I'm like, okay, I know there's those 4, that works. And I was talking to Miss Luxon, she goes, I think there might be more, like right in between here. So I folded that, but look, it doesn't work, does it? So sometimes using patty paper helps if you're having trouble finding them all. So there really is only 4. Four lines of symmetry. Let's talk about rotational. If we start here and go up to here, is that going to land on top of itself? It's not, is it? We have to go from here all the way up to here, which is what? And then 180. $90 degrees and 180. Okay? All right, last but not least, how about that one? What's the lines of symmetry on that one? There aren't any. See how good you're getting? You cannot fold this anywhere and have it land on itself. Jill doesn't believe me. Jill, if you draw a line here and fold it, this piece is not going to get on there, right? Can you see it? Are you thinking this way maybe?
She sees it. She just
Okay. How many rotational, what rotational is there on this one? From here to here and here to here. Just 90 and 100, right? Okay. 90 degrees and 180. All right, that's that. That one wasn't so bad, was it?